In this video, we are going to look at linear graphs and specifically transforming those graphs. And then we will revise increasing or decreasing the concepts and domain and range. Okay, so transforming graphs. Transforming refers to translating a graph or reflecting a graph. So let's look at translations first. The first example says translate y equals 3x plus 1 down by 3 units. Okay, so the first type of translation which we look at here is vertical translation. And of course we can also have horizontal translations, but we're not going to do those here. Okay, so translate y equals 3x plus 1 down by 3 units. If I'm moving up or down, it affects the c value, okay, of my linear graph. If I move down, I'm going to subtract the number of units. If I move up, I'm going to add that number of units. Okay, so up, add to c, and down, I'm going to subtract from c. Okay, so translate y equals 3x plus 1 down by 3 units. I will have y equals 3x plus 1, and I'm going to subtract 3 from the c. So that leaves me with y equals 3x minus 2 as my new equation. Okay, second example, translate y equals negative 2x minus 1 up by 4 units. So I'm going to have y equals negative 2x minus 1. I'm going to add 4 to move it up to the c value. And that simplifies to y equals negative 2x plus 3, which is the equation of my translated graph. Looking at reflections now, there are various reflections that you must be able to do, and understanding is the best way to succeed. Okay, so if I reflect over a line, it means that if I were to fold along that line, I would have a mirror image on either side of that line. Okay, so in this, so we're going to reflect over the x-axis. Now what you don't actually see here is that the graph's equation is y equals 2x plus 1. Sorry, that must have been cut off in my PDF here. Okay, so we want to reflect the line y equals 2x plus 1 over the x-axis. Okay, so if I reflect over the x-axis, okay, it means I'm folding along the x-axis. Okay, and what happens is that there is a vertical translation. Okay, so if I take particular points, okay, they are going to move vertically over the x-axis. Okay, that means that the x-coordinates actually stay the same. Okay, but what changes is the y-coordinate changes sign. So if I'm reflecting over the x-axis, y-coordinate changes sign, where x stays the same. And we can actually write a rule for this. So the rule for this is if I were to take any coordinate, okay, x, y, it changes to x stays the same and y changes sign. So if I started with a positive, it would go to a negative y. Okay, so if we look at particular coordinates, okay, this point here has the coordinates 1, 3. So reflecting over the x-axis, using the rule, it takes that coordinate 2 with the same x coordinate. The y coordinate changes sign, so it goes from positive 3 to negative 3. Okay, the same for this coordinate here. The coordinate here is 0, 1. Using the rule, it reflects to keep the same x coordinate, change the sign of the y coordinate, so 0, negative 1. Okay, so there, let's choose a point here. So if I have coordinate here on the line which has a point there on the line which has the coordinates -2, -3, that is going to be reflected vertically to have the same x-coordinate, -2, but the y-coordinate is going to change sign. So it's going to go from -3 to a +3. So -2, 3 is over there. Okay, so if I draw that line, sorry, this is going to be very rough. The line is there. So this line here is a reflection of the original graph over the x-axis. Okay, now you must be able to give the equation of the reflected graph, okay, if I reflect over the x-axis. And we keep the definition of reflecting over the x-axis in mind as we do this. So y equals 2x plus 1 reflected over the x-axis becomes, okay, now remember the y-coordinate changes sign. So I'm literally going to do that. I'm going to go from positive y to negative y, being equal to 2x plus 1. But that is not my final answer, because I can never leave an equation of a function not in standard form. So we're going to write this in standard form. Okay, write in standard form. To do that, we are going to solve for y. So I'm going to divide through by -1, okay, which leaves me with y equals -2x, -1. And that is my equation of the graph reflected over the x-axis. Now, let's reflect that same graph, y equals 2x plus 1, over the y-axis, okay? So again, if I were to fold over the y-axis, I must have mirror image on either side of the y-axis, which means that I'm going to have a horizontal reflection, okay? So the point 1, 3 is actually going to go to -1, 3, okay? So it's going to change over the y-axis, mirror image, okay? The coordinates -2, -3 reflected over the y-axis is going to go to +2, -3, okay? So what is happening here is that my y-coordinate is now staying the same, but my x-coordinate is changing sign. So y-coordinate stays the same, but my x-coordinate changes sign. Okay, now our rule, if we look at the points in the set of coordinates, if I have a point x, y, that is going to go to the x-coordinate changes sign, so it's going to go to -x. The y-coordinate stays the same, so it will just be y. Okay. You must also be able to give the equation of the reflected graph. So y equals 2x plus 1 reflected over the y-axis becomes, okay, now what happens when I reflect over the y-axis? The x-coordinate changes sign. So I'm literally going to do that, okay? Whereas I had y equals 2x, it's now going to become 2 times -x plus 1. So I'm literally changing the sign there, okay? And then write it in standard form. So get rid of the bracket. So 2 times -x is -2x plus 1. And that is the equation. Okay. Now, two more reflections. And these ones are a little bit more complex. Okay. But it is important to understand these. Okay. So reflecting over the line y equals x. Okay, now the line y equals x has the same x and y coordinates. So 1, 1, 2, 2, 3, 3, 4, 4, -1, -1, -2, and so forth. Okay, so if I just draw the line y equals to x, sorry, it's very hard to be accurate on this. But this is my line y equals x. Okay, so I want to reflect over that line, which means if I fold along that line, my graph must be a mirror image on either side. Okay, so if I look at the point 1, 3, folding over the line y equals x, that is going to go to 3, 1. Okay, let's look at an example of coordinates in the negatives. Okay, here I have coordinates -2, -3. If I reflect over the line y equals x, this goes to, I need to just double check. Sorry, my graph is not 100% accurate there, so it's going to look a little bit inaccurate. But it goes there, okay, reflecting over the line. So the coordinates here are -3, -2. So what has happened to the coordinates? Okay, you'll see that they have swapped over. So your x coordinate becomes your y coordinate, and your y coordinate becomes your x coordinate. Same for the second point. My -3 x became my y equals -3. My y coordinate of -2 became the x coordinate of -2. So when I reflect over the line y equals x, the x and y coordinates swap. Okay, so if I were to write this as a rule, okay, xy goes to, swap the x and the y, goes to yx. Okay, and again, you must be able to find the equation of the reflected line, reflected graph, sorry. So y equals 2x plus 1 reflected over y equals x becomes, okay, now how do we do this? We go according to what happens. The x and y coordinates swap. So I'm literally going to do that. Where I have a y, I have an x, equals. Where I had x, I'm now going to have y. Okay, so swap x and y. Okay, but now that cannot be my final answer because my equation must be in standard form. So it must be solved for y. So we need to solve this for y. Okay, so solve for y. Okay, so I'm going to subtract 2y. So I have -2y equals subtract x, -x plus 1. Divide through by -2. So -2, -2, -2. That leaves me with positive y equals x over 2. Okay, minus a half. There's my standard form equation. Okay, last reflection is over the line y equals -x. Okay, now y equals -x is where x, we have the same numerical values except that they have opposite sign. So where x is -1, y is +1. Where x is -2, y is +2. Where x is 1, y is -1. And you get the idea. Okay, so if I just draw a dotted form of the line y equals -x, that is the line that we are reflecting over, and we still have the same graph, y equals 2x plus 1. Okay, so again, if I reflect over a line, it's like folding along that line, and I must have mirror image across that line. Okay, so the point 0, 1, if I fold across the line, goes to the point -1, 0. Okay, so 0, 1, -1, 0. If I look at the point 1, 3, and I fold it across the line, okay, it's going to go to, I need to think about this, 1, 3, -3, 1, no, I have to double check. Sorry, -3, -1. Okay, -3, -1. That looks like, yeah, that's mirror image. Okay, -3, -1. Okay, let's look at an example with negative coordinates. So here we have the coordinates -2, -3. If I fold across the line, Okay, where does that take me? Okay, it takes me to 3, 2. Okay, so across the line, folding, I want mirror image. Okay, so it takes me to the coordinates 3, 2. So what is happening? From 1, 3, I go to -3, -1. From 0, 1, I go to -1, 0. From -2, -3, I go to 3, 2. What is happening is that my x and y coordinates are swapping, but they are also changing sign. So when we reflect over the line y equals x, x and y swap and change sign. Okay, so if I were to write a rule for this, for every coordinate, I start off with x, y, then they swap and they change sign. So from positive to negative, positive to negative. Okay, right, now you must also be able to find the equation of such a line. So starting off with y equals 2x plus 1 reflected over y equals negative 2x. Okay, what happens? My x and y swap and they change sign. So where I have a y, I'm going to have an x. But my y was positive, so now it's going to be negative x. Okay, where I had an x, I'm now going to have y, but change sign. So from positive, it's going to go to negative plus 1. Okay, now I need to write my final answer in standard form, which means I need to solve for y. So let's just simplify, get rid of the brackets. Okay, now solve for y. So I'm going to add 2y, add x, okay, divide by 2, and I have y equals x over 2 plus a half. That is my final equation in standard form. This is also our final reflection. So what I would like to do now is just quickly revise increasing or decreasing. Okay, now increasing and decreasing, we read from left to right. Okay, so to understand whether a graph is increasing means that as the x values increase, so we read from left to right, as the x values increase, what is happening to the y values? If the graph is increasing, it means the y values are increasing. Okay, so the graph increases where the y values increase. Okay, a decreasing graph is that as the x values increase, so again from left to right, what is happening to the y values? In this case, the y values are decreasing. So for both, the x values are increasing, but what defines whether the graph is increasing or decreasing is what is happening in the y values as we read from left to right. Okay, and a straight line either increases for the whole x is an element of R, okay, unless it's been restricted, or it decreases. So it doesn't increase or decrease, it either increases or decreases. So this graph here is a decreasing graph because as I move from left to right, okay, so looking at my x coordinates, as I move from left to right, okay, what is happening to the y coordinates? They are slowly decreasing. Okay, so this is a decreasing graph. So this graph decreases for x is an element of R. If we know that this graph is not restricted and continues forevermore. Okay. And to revise domain and range, remember that the domain are all the x values for which the graph exists. So if I select an x value, say x equals -3, and I draw a vertical line and I'm able to find the graph, it means that the graph exists at that value x equals -3. Okay, so the domain is the set of all x values for which the graph exists. Okay, the range, on the other hand, is the set of all the y values for which the graph exists. So if I were to pick a y value, say y equals 2, and if I were to draw a horizontal line to find the graph, and if I find the graph, it means that the graph exists at that y value. So the range is all the y values for which I can find the graph. Okay, now unless a linear graph is restricted, the domain will always be x is an element of reals, and the range will always be y is an element of reals.